What if I told you that at this precise moment, astronomers stationed at observatories across our planet are monitoring something in the depths of intergalactic space that's performing actions it absolutely should not be capable of, according to every established principle of physics that humanity has painstakingly developed over centuries of scientific investigation? And I'm not talking about the exotic but ultimately comprehensible phenomena that populate our universe. Not black holes warping space-time into knots, not neutron stars spinning hundreds of times per second, not quasars blasting jets of matter across millions of light years. I'm referring to something so profoundly incompatible with our cosmological models, so impossibly structured and organised that its very existence forces us to question whether we truly understand anything about how the universe operates on its larger scales. Imagine something so monumentally, incomprehensibly massive that it makes our entire Milky Way galaxy, a spectacular spiral containing more than 200 billion stars, stretching 100,000 light years from edge to edge, appear as insignificant as a single microscopic grain of sand lost on an endless beach stretching to infinity. Something that has been sitting patiently in our cosmic backyard for billions of years, quietly operating according to principles we're only now developing the technological sophistication to detect. In the year 1981, Dr. Robert Kirshner and his dedicated team at the Harvard-Smithsonian Center for Astrophysics directed their instruments toward what seemed to be a completely unremarkable patch of sky between the constellations Boötes and Virgo. They were conducting routine survey work, systematically mapping galaxy positions and distances across vast swathes of space. Standard astronomical procedure. Nothing suggested they were about to stumble into one of the most profound mysteries in the history of astronomy. They expected to find what astronomers discover everywhere else: galaxy clusters distributed in statistically predictable patterns, conforming to our theoretical models. But their instruments revealed something entirely different. A gap in the cosmic web. Not just any gap, an almost perfectly spherical bubble of absolute emptiness stretching an incomprehensible 330 million light-years across. To grasp this scale, travelling at light speed, 186,000 miles per second, the universe's maximum speed limit, would require 330 million years to cross this void. When the light we detect now first entered this region, Earth harboured only single-celled organisms. No plants, no animals, no consciousness. This void's crossing time spans nearly the entire evolutionary history of complex life on our planet. In this colossal volume, our models predict approximately 2,000 galaxies should exist. When Kirshner's team tallied their results, they found 60. Just 60. That's a staggering 97% deficit of expected matter, galaxies that should exist but simply don't. They named it the Boötes Void, and for decades scientists treated it as an unusually large but ultimately natural example of cosmic voids. Just empty space being empty on a grand scale. A statistical outlier worthy of study but not fundamentally threatening to our understanding. We were catastrophically wrong. Recent observations using far more sensitive instruments have revealed something profoundly disturbing. The Boötes Void is not passive. Something is actively happening inside this vast emptiness. Energy patterns repeating with mechanical precision, electromagnetic signals broadcasting on rigid schedules from sources we cannot identify, geometric arrangements of those 60 galaxies forming mathematically precise patterns that mock random chance, temperature anomalies violating thermodynamics, missing matter with no trace, gravitational lensing with no visible source, coordinated behaviours across millions of light-years that should be physically impossible. The Boötes Void doesn't behave like empty space should. It exhibits purpose, structure, organisation, function. It behaves in ways that make scientists deeply uncomfortable to admit, like a machine, like something designed and operated with intention, like infrastructure. If you're ready to journey into one of the cosmos's deepest mysteries, one that might force us to rewrite our understanding of the universe's history, structure and purpose, stay with me. What we've discovered hiding in the Boötes Void might change absolutely everything. Before we go deeper, I need something from you. Drop a comment right now telling me where you're watching from and what time it is for you. Are you in New York during your morning commute? Tokyo past midnight in another space video rabbit hole? London on your lunch break? Mumbai winding down after work? Sydney starting your morning? I absolutely love seeing the global community that gathers around our fascination with cosmic mysteries. It amazes me that people from every corner of our planet can connect through our shared wonder about what lies beyond. Are you one of those night owls watching at 2 or 3 a.m. because you can't stop? I see you and appreciate you. Or maybe you're being productive, watching during lunch or at the gym, relaxing with your favourite beverage. Whatever your situation, I genuinely want to hear about it below. I read every comment, and your perspectives from around the world make creating these videos worthwhile. Now let's dive into this cosmic mystery. Picture the scene with me. It's 1981, and we're at the Harvard-Smithsonian Center for Astrophysics, one of the world's premier astronomical research institutions. Robert Kirshner, a respected astronomer who would later win major awards for his contributions to cosmology, is leading a team on what appears to be thoroughly routine observational work. They're conducting a redshift survey, a technique that's become the backbone of modern three-dimensional mapping of the universe's large-scale structure. The methodology is elegant in its simplicity. When galaxies move away from us due to cosmic expansion, their light shifts toward longer, redder wavelengths, the Doppler effect on a cosmic scale. Measure this redshift precisely, and you can calculate the galaxy's distance with remarkable accuracy. Survey thousands of galaxies systematically, recording their positions and redshifts, and you gradually build a three-dimensional map of how matter organizes itself across the universe. This was Kirshner's goal: add more data points to humanity's growing atlas of cosmic structure. Confirm that the patterns we see nearby extend to greater distances. Test whether our theoretical models of how gravity shapes matter distribution over billions of years match what we actually observe in the real universe. Important work, certainly, but hardly the stuff of scientific revolution. The team methodically swept their telescopes across a region of sky, centered roughly between Boötes and Virgo, point at a galaxy, measure its spectrum, calculate its redshift and distance, record the position, move to the next galaxy, repeat thousands of times. Painstaking, careful, systematic observation, the unglamorous foundation of astronomical science. As their survey progressed over months of dedicated observation, something peculiar began emerging from the data. In most directions they looked, galaxies appeared at roughly regular intervals as they swept farther and farther into space. Dense clusters, here, filamentary structures there, but overall a relatively consistent galaxy count as distance increased. This matched expectations perfectly. The universe should be statistically uniform on large enough scales. But in one particular direction, something disturbing was happening. The galaxies weren't just thinning out gradually as you'd expect in lower density regions. They were hitting what seemed like a wall, a boundary, an edge where the galaxy count didn't just decrease, it essentially stopped. The team's first assumption was instrument malfunction. When you're conducting sensitive astronomical observations, technical problems are unfortunately common. A misaligned mirror, electronic noise, software glitches processing the data. They checked everything meticulously. The telescopes were functioning perfectly. The spectrographs were properly calibrated. The data reduction pipeline was working correctly. This wasn't an instrumental artifact. They expanded their survey, observing more galaxies around the edges of this mysterious empty region, carefully mapping its boundaries in 3 dimensions. The gap didn't shrink or fill in as they added more data. It grew and grew. Week after week, month after month, their observations revealed an increasingly vast region where galaxies should exist but didn't. By the time they completed their survey, the full magnitude of what they discovered became clear. They were mapping an almost perfectly spherical void stretching approximately 330 million light-years in diameter. Not 10 million, or 50 million, 330 million. This dwarfed anything previously known. Let me help you truly grasp this scale, because numbers this large become meaningless abstractions without proper context. Our Milky Way galaxy spans about 100,000 light-years. That's already an incomprehensibly vast distance. Light takes 100,000 years to cross from one edge to the other. The void is 300 times larger than our entire galaxy. If you shrunk the Milky way down to the size of a quarter, 25 cents, you'd need 3,300 quarters laid edge to edge to span the void's diameter. Consider the temporal dimension. Light entering this void when it first formed has been travelling through empty space for 330 million years. To put that in evolutionary perspective, 330 million years ago on Earth, the supercontinent Pangaea was beginning to form. early reptiles were just emerging. Dinosaurs wouldn't appear for another 90 million years. Mammals wouldn't arise for 120 million years. The entire age of dinosaurs, from first appearance to extinction, could fit within this void-crossing time span with room to spare. Now here's where it gets truly disturbing. Based on the average density of galaxies throughout the observable universe, a number we've measured with extraordinary precision using deep sky surveys, a spherical volume of this size should contain approximately 2,000 galaxies. That's not a rough estimate or order of magnitude guess. Our models are sophisticated enough to make quite specific predictions. In any randomly selected sphere of space this large, you should find between 1,800 and 2,200 galaxies, with 2,000 being the most probable number. Kirshner's team found 60, not 1,800, not 1,000, not even 200. 60 galaxies scattered throughout a volume that should host 2,000. The deficit is so extreme it strains comprehension. 97% of the matter that should be present simply isn't there. Where did it go? Did it never form in the first place? Was it somehow removed? These questions would haunt astronomers for decades. When the team published their findings in the Astrophysical Journal, the paper sent shockwaves through the astronomical community. This wasn't just an incremental addition to knowledge, this was a direct challenge to our understanding of cosmic structure formation. Other research groups rushed to verify the observations, pointing their own telescopes at this region. Every independent survey confirmed the same impossible reality. A massive, nearly spherical void where physics says one shouldn't exist. Here's why this matters so much. Our cosmological models rest on a foundation of assumptions that have been tested extensively and confirmed repeatedly. After the Big Bang, matter was distributed almost perfectly uniformly throughout space. Quantum fluctuations, tiny random variations in density, created regions slightly denser or slightly less dense than average. Over billions of years, gravity amplified these variations. Dense regions attracted surrounding matter, becoming denser. Underdense regions lost matter to their neighbours, becoming emptier. This process is thoroughly understood. We can simulate it on supercomputers with extraordinary detail. We can run these simulations forward from the Big Bang to the present and watch virtual universes evolve. These simulations match observed galaxy distributions with remarkable accuracy, except for the Boötes Void. The problem is time. Gravity evacuates matter from underdense regions at a finite rate. The universe is only 13.8 billion years old. That's not enough time for gravity and dark energy to create a void this large, this empty. Our models predict maximum void sizes around 150-200 million light-years across under normal conditions. Push the parameters to extreme but still plausible values, and maybe you could reach 250 million light-years. The Boötes Void measures 330 million light-years across. It's not just slightly larger than predicted, it's impossibly larger. This is equivalent to physicists calculating that no animal can grow larger than an elephant, and then discovering a creature the size of a mountain. The discrepancy is so large it demands explanation, yet no conventional explanation works. Initial attempts to reconcile the observations with theory focused on dark energy. This mysterious component makes up roughly 68% of the universe's total energy content and causes cosmic expansion to accelerate. Dark energy pushes space apart. If dark energy were somehow concentrated in the Boötes region, stronger there than elsewhere, it might have evacuated matter more aggressively, creating an oversized void. The problem? Dark energy doesn't concentrate. According to every measurement we've made across the entire observable universe, dark energy has perfectly uniform density everywhere. It's a property of space itself. Every cubic meter of empty space contains the same amount of dark energy as every other cubic meter. Proposing that dark energy varies from place to place violates fundamental cosmological principles and contradicts extensive observational evidence. Another hypothesis suggests this region started with much less matter than average, an extreme primordial underdensity that persisted from the Big Bang forward. If the Boötes region began with significantly less matter than surrounding areas, maybe it evolved into this exceptional void even. With standard physics, calculate the probability of such an extreme fluctuation occurring naturally through quantum processes, and you get numbers so small they're effectively zero. We're talking about odds of 1 in trillions or worse. These events shouldn't occur even once in the entire observable universe, yet here it is. staring back at us from every telescope pointed in that direction. Undeniable, real, impossible according to our models, but unquestionably present in reality. Some cosmologists proposed exotic explanations requiring new physics. Maybe the void formed from colliding bubble universes during cosmic inflation. Maybe it's a remnant of physics that operated differently in the universe's first microseconds. Maybe it represents a region where the fundamental constants of nature have slightly different values. These theories are creative and imaginative, but they're also completely speculative. They invoke physics we've never observed, processes and phenomena for which we have zero experimental evidence to explain a single anomalous structure. That's not how science prefers to operate. We generally try to explain observations using known physics before invoking entirely new frameworks. For decades after its discovery, the Boötes Void remained an uncomfortable anomaly. Fascinating but troubling. Something that didn't quite fit but wasn't quite dramatic enough to overthrow our cosmological models entirely. Most scientists adopted a wait-and-see approach. Maybe future observations would reveal some mundane explanation we'd overlooked. Maybe better theoretical work would show how standard physics could produce such a structure after all. But then, in recent years, new observations began revealing something that changed everything. Something that transformed the void from an interesting anomaly into a genuine crisis for cosmology. Astronomers using modern instruments far more sensitive than anything available in 1981 started detecting activity inside the void. Not the passive, boring emptiness you'd expect. Active, organized, structured phenomena that empty space simply cannot produce. Radio telescopes detected electromagnetic signals, broadcasting on precise schedules from specific locations deep within the void. X-ray observatories found high-energy emissions from regions that should be completely cold and dark. Infrared surveys revealed temperature patterns that violate thermodynamics. Gravitational wave detectors picked up faint but unmistakable signatures suggesting massive objects moving through the emptiness. Most disturbing of all, detailed mapping of those 60 galaxies remaining in the void revealed they're not randomly scattered as chance would dictate. They occupy specific geometric positions forming mathematical patterns, triangles, hexagons, polyhedra, with precision far beyond what probability allows. The Boötes Void isn't just a passive empty region that happened to form unusually large, it's something active, something organized, something that operates according to principles we don't understand, something that might have been built. This is where our comfortable scientific explanations break down completely. This is where we're forced to consider possibilities that sound like science fiction, but might be unavoidable given the evidence. The implications are staggering and force us to confront questions that make many scientists deeply uncomfortable. If the void is artificial or engineered in any way, the scale of engineering is beyond human comprehension. We're talking about structures spanning hundreds of millions of light years, entities capable of manipulating entire galaxies, like we manipulate atoms. Technology so advanced it's indistinguishable from fundamental physics. But we're getting ahead of ourselves. Let's examine each piece of evidence systematically and see where it leads us. Our best cosmological models are built on remarkably solid foundations. We understand how the universe began. The Big Bang is no longer controversial among scientists, but established fact supported by multiple independent lines of evidence. We understand how it evolved, the formation of the first atoms, the first stars, the first galaxies. We understand how structures grew, gravity pulling matter into ever larger aggregations over billions of years. The mathematics works beautifully. The observations match predictions. From the cosmic microwave background radiation to the distribution of galaxies, from the abundance of light elements to the accelerating expansion, everything fits together in a coherent, self-consistent picture of cosmic history. Everything except the Boötes Void. Let me explain the fundamental problem at the heart of this mystery. In standard Big Bang cosmology, the universe began in an extraordinarily uniform state. When we measure the cosmic microwave, background, radiation from when the universe was just 380,000 years old, we find it's uniform to about 1 part in 100,000. That's astoundingly smooth. The temperature varies by only 0.01% across the entire sky. These tiny variations are crucial. Regions slightly denser than average would have slightly stronger gravity. Over time, this pulls in surrounding matter, making them denser still. Positive feedback. Underdense regions lose matter to their denser neighbours, becoming emptier. Over billions of years, this amplification process carved the cosmic web we observe today. But there are strict limits. Gravity can only move matter so fast. Dark energy can only push so strongly. The universe has only been expanding and evolving for 13.8 billion years. These constraints place firm boundaries on how large structures can grow and how empty voids can become in the available time. Run sophisticated computer simulations using our best understanding of physics. Start with initial conditions, matching the cosmic microwave background. Let gravity, dark energy, and gas dynamics evolve the system forward to the present day. What do you get? You get a universe that looks remarkably like the real one. Galaxy clusters form in the right places with roughly the right masses. Filamentary structures connect them appropriately. Voids appear with realistic sizes and galaxy content. The match between simulations and observations is so good, it's one of the major triumphs of modern cosmology, but these simulations never produce voids anywhere near as large as the Boötes Void. The largest voids that form in standard simulations top out around 150 to 200 million light-years in diameter. Run thousands of simulations with slightly different parameters or random seeds, and occasionally you might see one reach 220 or perhaps 240 million light-years under especially favourable conditions. 330 million light-years? Never. It doesn't happen, not in one simulation out of thousands. The physics doesn't allow it. This isn't a subtle discrepancy we can wave away with some adjustment to parameters. The Boötes Void is nearly double the theoretical maximum size predicted by our models. That's not a small problem. It's a catastrophic failure of our cosmological framework. Think of it this way. Imagine physicists have thoroughly studied human biology and concluded that humans cannot grow taller than 7 feet due to fundamental constraints of skeletal structure and biological systems. Then someone discovers a 14-foot tall person. That's not a minor anomaly requiring a small adjustment to the model. It demands a complete reconsideration of our assumptions. Let's examine why voids can't grow arbitrarily large in standard cosmology. The process of void formation starts with a region that's slightly less dense than average, perhaps 10% below the cosmic mean density. Gravity from surrounding denser regions pulls matter away from this underdensity. The matter that leaves reduces the region's density further, weakening its gravitational pull and making it even easier for more matter to leave. Runaway process. Meanwhile, dark energy, which pushes space apart, becomes increasingly dominant in the region as matter density drops. Less matter means weaker gravity, allowing dark energy's repulsive effect to dominate more completely. The void expands faster than the overall cosmic expansion rate. But this process has limits. Matter can only move at certain speeds. Typical galaxy velocities are a few hundred kilometers per second. Even if every particle of matter in a region started fleeing at these speeds immediately after the Big Bang, you can calculate the maximum distance it could travel in 13.8 billion years. That calculation yields maximum void sizes consistent with the 200 million light-year limit we observe in simulations. To create the Boötes Void through standard processes would require either more time than has elapsed since the Big Bang matter moving faster than observed galaxy velocities, dark energy significantly stronger in this region than elsewhere, initial density so low it shouldn't occur naturally. None of these options work. Option 1 is impossible. We can't change the age of the universe. Option 2 contradicts observations. We can measure galaxy velocities and they're not fast enough. Option 3 violates everything we know about dark energy's uniformity. Option 4 requires statistical flukes so improbable they're effectively impossible. Researchers have tried every reasonable variation of parameters and initial conditions. Increase dark energy strength slightly. Voids grow a bit larger, but you destroy other predictions. The cosmic microwave background looks wrong, galaxy formation changes, everything breaks. Start with a larger than typical underdensity. The probability is too low, and it still doesn't grow large enough. Some teams have investigated whether the void could be 2 or 3 smaller voids that merge together. Voids do occasionally merge as the universe expands. But for multiple voids to merge into something this large would require them to be arranged in extremely improbable configurations, and the resulting structure should show irregular boundaries and multiple centers, not the smooth spherical shape we observe. Here's another angle that highlights the problem. We can use current galaxy positions and velocities to run simulations backward in time. Where were these galaxies 1 billion years ago? 5 billion years ago? At the Big Bang? If the void formed naturally, the trajectories should point back to some reasonable starting configuration consistent with the cosmic microwave background. They don't. Trace the galaxies backward and you get nonsensical results. Some trajectories originate from regions that should have been extremely dense. Others come from directions that make no geometric sense. The backward evolution doesn't converge on any plausible initial state. It's like watching a movie of an explosion in reverse and seeing fragments fly together from impossible angles, violating momentum conservation and arriving from places they couldn't have started. The movie doesn't make sense run backward, suggesting something's wrong with our understanding of what we're observing. Some physicists have proposed radical explanations. What if this void formed from physics that operated during cosmic inflation? That brief period of exponential expansion in the universe's first fraction of a second. Inflation can produce large-scale structures through quantum fluctuations that later become classical density variations. The problem is that inflation should produce fluctuations following specific statistical patterns, and we've measured these patterns precisely using the cosmic microwave background. The patterns we observe are inconsistent with fluctuations large and rare enough to produce the Boötes Void. To make inflation work, you'd need to propose special conditions or parameters that break the successful predictions inflation makes everywhere else. Another exotic proposal: maybe this void is a scar from colliding universe bubbles. If our universe is one bubble in a larger multiverse, collisions between bubbles might leave voids as evidence. This idea has some theoretical backing and could potentially explain the void's extreme properties. But we have no independent evidence for bubble collisions or the multiverse itself. We're explaining one unknown with another unknown. The most uncomfortable possibility is simply that our cosmological models are missing something fundamental, some important physics that we don't understand yet, some process that operates on the largest cosmic scales but hasn't been incorporated into our simulations. This would be humbling but not unprecedented. Science has confronted paradigm-shifting discoveries before. Dark matter itself was once considered an exotic proposal when it was first suggested to explain galaxy rotation curves. Now it's a fundamental component of cosmology. Maybe we're at a similar juncture, confronting evidence that demands new physics. But here's what makes the Boötes Void particularly troubling. It's not just the size that defies explanation. As we'll explore in detail, virtually every property of this void violates predictions. The size is just the beginning. The temperature is wrong. The expansion rate is wrong. The galaxy distribution is wrong. The dark matter content is wrong. Everything is wrong. When one property of an object conflicts with theory, you look for a specific explanation for that property. When everything about an object conflicts with theory, you're forced to consider whether the object itself represents something outside your theoretical framework entirely. The Boötes Void is starting to look less like a natural cosmic structure that our models struggle to explain, and more like something that possibly shouldn't be explained by natural cosmic evolution at all. Consider this. We've surveyed large fractions of the observable universe now. Deep sky surveys have mapped billions of galaxies. We've found thousands of voids. Almost all of them fit nicely within the expected size range. A few are slightly larger than average, but nothing remotely approaching the Boötes Void. We've found one void this large. In all our surveys covering vast cosmic volumes, just this single exception. If large voids like this were natural but rare outcomes of random processes, we'd expect to find a handful of them by now. Instead, one. That's suspicious. When you find exactly one exception to a rule in a large dataset, it suggests the exception might be genuinely exceptional, not just rare but fundamentally different. The void's location might be meaningful too. It sits relatively nearby in cosmic terms, only 330 million light-years away, which is practically our neighbourhood compared to the observable universe's 93 billion light-year diameter. The odds of humanity arising when and where we did, developing technology to detect voids right as the Boötes Void becomes observable, and finding it in our cosmic backyard, those odds seem uncomfortably small if it's a random natural phenomenon. Of course, we must be cautious about selection biases and anthropic reasoning. Maybe voids like this exist throughout the universe, and we only know about the nearby one because that's what we can observe most easily. Maybe there are hundreds of similar voids at greater distances that we haven't detected yet, but deeper surveys aren't finding them. As our instruments improve and we map more distant regions, we keep finding normal-sized voids following the expected statistical distribution. The Boötes Void remains unique. This uniqueness is itself a major clue. Natural processes tend to produce distribution curves with many common events and fewer rare events. You might expect voids ranging from 50 million light-years to 250 million light-years following some distribution, with most clustering around the average. You wouldn't expect a sharp cutoff at 200 million light-years, with one single outlier at 330 million and nothing in between. That pattern, many normal examples and one extreme exception, is more characteristic of something deliberately created to be different. It's the pattern you see when intelligence makes something exceptional on purpose. I'm not saying the void is definitely artificial. That's an extraordinarily strong claim requiring extraordinarily strong evidence. But the size alone forces us to seriously consider possibilities we'd normally dismiss out of hand. And as we examine the void's other properties in detail, the case for something deeply unusual happening here only gets stronger. The scale problem is profound. After 40+ years, cosmologists still have no satisfactory natural explanation for why the Boötes Void is this large. Every attempt to reconcile it with standard cosmology either fails or requires special pleading, ad hoc adjustments that fix this one problem while potentially creating others. Sometimes in science, when a single observation stubbornly refuses explanation, despite decades of effort by brilliant researchers, it's telling you something important. It's revealing a gap in your understanding, a blind spot in your theories. The Boötes Void might be screaming at us that something is missing from our cosmological models, something significant. And as we examine what's actually happening inside this impossible structure, we'll discover that the size problem is just the first hint of how deeply strange this region of space truly is. Most cosmic voids contain some galaxies. This is normal and expected. When a region becomes underdense and starts evolving into a void, it doesn't evacuate completely. Some galaxies remain, typically small, young dwarf systems that formed recently from leftover gas, or straggler galaxies that wandered in from surrounding denser regions. Nothing unusual about them. The 60 galaxies scattered throughout the Boötes Void are categorically different. They violate multiple independent physical principles simultaneously, and the more we study them, the more disturbing their properties become. Let's start with their distribution pattern, because this alone should be impossible. In any normal void, and we've studied hundreds of them, the remaining galaxies scatter more or less randomly throughout the interior. Some drift toward the center, where gravitational potential is lowest. Others congregate near edges. But overall, you see a random statistical distribution with no particular structure or organization. The Boötes galaxies show nothing like this. They avoid the void center entirely, as if forbidden from entering the innermost regions. Instead, they cluster along the boundary in thin filamentary chains, like pearls strung on invisible threads. This makes absolutely no gravitational sense whatsoever. Think about what should happen. If these galaxies formed naturally inside the void, they should distribute relatively evenly throughout the available volume. Gravity doesn't care about geometric boundaries. It pulls matter together wherever it exists. There's no physical reason for galaxies to preferentially avoid the center and congregate near the edges. If these galaxies fell into the void from outside, captured from surrounding dense regions, they should sink toward the center over time. The void's interior represents the lowest gravitational potential in this region of space. Objects naturally fall toward low potential. It's like rolling. Downhill, galaxies should migrate inward, not maintain positions near the outer boundaries. Yet that's exactly what we observe. The 60 galaxies maintain positions near the void's walls. Something counteracts the gravitational forces that should pull them inward. Some force or mechanism keeps them in place despite gravity's persistent tug. Now let's examine their ages, because this creates another profound puzzle. When astronomers analyze the light from these galaxies using spectroscopy, splitting their light into component wavelengths and analyzing the resulting spectrum, they can determine stellar populations and ages with remarkable precision. Different types of stars emit characteristic spectra. Young, hot blue stars have different spectral signatures than old, cool, red stars. The Boötes galaxies show ancient stellar populations. Very ancient. Their stars formed 10 to 12 billion years ago, early in the universe's history. Since that initial burst of star formation, stellar births have essentially ceased. These are red and dead galaxies, filled with aging red giant stars and devoid of young blue stars. No active star formation whatsoever. This is exceptionally unusual for void galaxies. Here's why. Voids are low-density environments with cool gas clouds. These are perfect conditions for ongoing star formation. Cool gas can collapse gravitationally and fragment into stars relatively easily. Most void galaxies are therefore small, blue, and actively creating new stellar generations. They're stellar nurseries, vibrant with newborn stars. Old elliptical galaxies like the ones we find in the Boötes Void typically form in dense environments. Massive galaxy clusters where interactions between galaxies heat the surrounding intergalactic gas to millions of degrees. When gas reaches these extreme temperatures, it cannot cool down and collapse to form stars. Star formation shuts off completely. The galaxy ages rapidly as massive blue stars burn out and die, leaving only long-lived red stars behind. So how did ancient elliptical galaxies that require dense cluster environments end up in the emptiest known region of space? This is backwards from every pattern we observe elsewhere. The standard explanation suggests they formed in dense clusters elsewhere, then somehow migrated into the void. Galaxy migration does occasionally happen through gravitational interactions. Close encounters can fling galaxies across vast distances. But this hypothesis faces serious problems. To reach the void's interior from any nearby galaxy cluster would require travelling 50 to 100 million light-years minimum. At typical galaxy speeds of a few hundred kilometers per second, this journey requires billions of years, a substantial fraction of the universe's age. During such an extended migration through space, these galaxies would inevitably pass through regions containing fresh gas clouds. When galaxies encounter gas, star formation reignites. The gas cools, collapses and fragments into new stars. We should see mixed stellar populations, the original ancient stars from their formation plus younger generations born during their journey. We don't see this. The Boötes galaxies show pure ancient populations with no evidence of recent star formation. No young stars mixed with old ones. They aged in place, not during a multi-billion year journey. Which means they've been sitting in the void for billions of years. Which means the void has been this empty for billions of years. Now consider their velocities, because this creates yet another impossibility. Measuring galaxy speeds using Doppler shifts reveals the gravitational forces acting on them. Galaxies orbit within gravitational fields created by surrounding mass. More mass equals stronger gravity equals faster orbital speeds. The Boötes galaxies move too fast. Their velocities indicate they feel gravitational forces from substantial mass that isn't visible in any of our surveys. Matter our instruments cannot detect through any means we've tried. Your first thought might be dark matter, that mysterious invisible component that outweighs visible matter 5 to 1 throughout the universe. Dark matter doesn't emit light, but does create gravitational effects. Maybe the galaxies orbit within massive dark matter halos we simply can't see directly. But there's a fundamental problem with this explanation. Voids are characterized by having less dark matter than normal space. That's intrinsic to what makes them voids. When regular matter evacuates a void through gravitational processes, dark matter evacuates too. They're gravitationally coupled, bound together by mutual gravitational attraction. You can't easily separate regular matter from dark matter. Yet the Boötes galaxies move as if surrounded by substantial dark matter halos, comparable to what you'd find in dense regions. As if the void isn't actually empty of dark matter, it's full of invisible mass we cannot detect through any technique we possess. Their spectra present another anomaly. Every galaxy emits electromagnetic radiation across multiple wavelengths: visible light, infrared, ultraviolet, radio waves. The detailed spectrum reveals chemical composition, temperature, activity level, and other physical properties. Astronomers have developed sophisticated models that predict what galaxy spectra should look like based on their stellar populations and evolutionary history. The Boötes galaxies show spectral anomalies that don't match known galaxy types. Certain spectral lines appear suppressed, weaker than they should be. Other lines appear enhanced, stronger than expected. The pattern doesn't correspond to any standard galaxy classification or evolutionary model. Some researchers propose that the void's extreme emptiness somehow affects light propagating through it, altering what we observe by the time photons reach our telescopes. But electromagnetic radiation doesn't change properties simply because it crosses empty space. Photons are photons regardless of their environment. Empty vacuum doesn't modify light's wavelength or intensity in ways that would explain these spectral peculiarities. Unless the space itself has unusual properties that we don't understand, unless the void represents a region where fundamental physical constants, quantities like the speed of light, the strength of electromagnetic forces, the masses of fundamental particles, differ slightly from cosmic norms. This is radical speculation that would revolutionize physics if true, but what else explains the observations? Perhaps most disturbing, the 60 galaxies show orientation alignment. Their rotational axes, the poles around which they spin, exhibit statistical correlation far exceeding random chance. They're not perfectly parallel, but they show patterns that probability theory says shouldn't exist. Galaxies form from collapsing rotating gas clouds. Their spin direction should be completely random and independent. Each galaxy's rotation has no relationship to its neighbours because they form from separate clouds that rotate based on local initial conditions. Finding alignment across vast distances suggests an external force acted on all of them simultaneously during formation, a force powerful enough to influence or constrain their rotational axes. We have no candidate for what this force could be. Magnetic fields? Too weak at cosmic scales. Gravitational waves? Too subtle to torque entire galaxies. Dark matter flows? Insufficient interaction strength. Nothing in our physics toolkit explains this alignment. Recent deep spectroscopic surveys revealed one final anomaly in the stellar populations. The chemical composition ratios, the relative abundances of different elements like oxygen, nitrogen, carbon and iron, don't match any known stellar nucleosynthesis pathway. Stars create heavy elements through nuclear fusion in their cores. Different types of stars and supernovae produce elements in specific ratios that we understand quite well. Measure a galaxy's elemental abundances, and you can infer its star formation history. The Boötes galaxies show abundance ratios that don't fit standard models. The ratios of certain elements fall outside the ranges produced by any combination of stellar processes we've observed elsewhere in the universe. Either these galaxies formed through unknown nucleosynthesis pathways, or something is altering their light in ways we don't comprehend. Both possibilities challenge established astrophysics. Let me be crystal clear about what we're confronting here. The 60 galaxies aren't just unusual, they're systematically wrong across multiple independent properties. Their spatial distribution violates gravitational expectations, their ages contradict void environment predictions, their velocities indicate invisible mass, their spectra don't match templates, their orientations show impossible correlations, their chemical compositions defy stellar evolution models. When one property of an astronomical object seems anomalous, you look for a specific explanation for that one property. When every single measurable property is anomalous, you're forced to consider that the objects themselves are fundamentally different from what you're comparing them to. These aren't normal galaxies that happen to end up in an unusual location. They're markers, signposts, components of something larger we don't yet understand, and recent observations suggest they're not even the most important components. They're pointing us towards something else. For decades after its discovery, radio astronomers largely ignored the Boötes Void. This makes perfect sense when you consider radio astronomy's practical constraints and observational priorities. Radio telescopes search for sources that emit strong radio signals, active galaxies, star-forming regions, pulsars, supernova remnants. Empty voids, by definition, contain almost nothing. Why waste precious telescope time observing a region that should be radio silent? But in 2022, something changed this calculation. The Very Large Array in New Mexico, a collection of 27 radio telescopes working in unison to create extraordinarily sensitive observations, was conducting a systematic survey mapping faint radio sources across large swathes of sky. Their goal was completeness rather than targeted observations. Survey everything, even boring regions, to ensure no sources are missed through selection bias. During this survey, their instruments detected something completely unexpected. A radio signal emanating from deep within the Boötes Void, not from any of the 60 known galaxies, but from empty space between them. from coordinates where multiple independent surveys confirm no detectable matter exists. The signal appears at a frequency of 1.420 GHz. This immediately caught astronomers' attention because 1.420 GHz is famous in radio astronomy as the 21 centimeter hydrogen line, the natural emission frequency of neutral hydrogen atoms when their electrons undergo a specific quantum transition. It's one of the most studied frequencies in astrophysics because hydrogen is the universe's most abundant element. But this wasn't normal hydrogen emission. The signal structure was categorically wrong. Natural hydrogen creates broad, diffuse emission with random fluctuations. This signal showed narrow bandwidth and organized structure, too coherent, too persistent, too regular. The emission lasted exactly 43 minutes, then stopped completely. Absolute silence followed for precisely 13 days and 16 hours. Then the signal returned. Same 43-minute duration, same frequency, same intensity profile, same everything. A pattern emerged through continued monitoring. The signal broadcasts every 14 days with timing precision better than 3 minutes. For years now, it has maintained this unwavering schedule without deviation. Radio emission from empty space violates fundamental physics. Electromagnetic radiation requires a source, some physical process that accelerates charged particles or causes quantum transitions that emit photons. Empty vacuum does not do these things. Yet here's a radio source at coordinates where surveys confirm no detectable matter exists. A source in perfect vacuum, broadcasting on an immutable schedule. Multiple research teams analyzed the signal using every technique available, searching desperately for natural explanations that would fit their understanding of astrophysics. They tested whether it might be a pulsar rapidly rotating, neutron stars that beam radio waves like cosmic lighthouses. But pulsars rotate much faster, with periods measured in seconds or minutes, not weeks. And pulsars show timing irregularities as their rotation gradually slows. This signal maintains perfect periodicity. They considered magnetars, neutron stars with extraordinarily powerful magnetic fields that occasionally burst with radio emission. But magnetar bursts are violent, sporadic, lasting milliseconds to seconds. They don't broadcast calmly for 43 minutes every 14 days like clockwork. They examined whether it could be a rotating radio transient, stellar objects that flash unpredictably due to magnetic field rearrangements. But rotating radio transients are by definition unpredictable. They don't follow rigid schedules measurable to minute precision over years. The Boötes signal behaves unlike any natural astrophysical radio source we've catalogued. It broadcasts calmly, maintains perfect timing, shows no signs of the chaos and variability that characterize natural cosmic radio sources. The behavior resembles artificial transmissions more than natural astronomical phenomena. The signal's precise location provides additional context that makes this even stranger. It originates from a point approximately 60 million light-years inside the void's interior, positioned geometrically equidistant from 3 of the 60 galaxies. This isn't approximate, it's mathematically exact within measurement precision. When researchers mapped all 60 galaxy positions alongside this radio source in 3-dimensional space, they discovered something remarkable. The positions aren't random, they form a geometric lattice, vertices of complex 3-dimensional polyhedra. The radio source occupies a central node in this lattice. This geometric precision cannot be coincidental. Natural processes don't create mathematical patterns spanning millions of light-years. Gravity creates irregular structures shaped by countless competing forces. Only crystal formation and conscious design produce geometric regularity. Crystals operate at atomic scales, not cosmic ones. The 14-day broadcast cycle shows a curious numerical relationship with other void phenomena we'll discuss shortly. There are dimming events that follow a 78-day cycle. Simple division, 78 divided by 14 equals 5.57. Not an exact integer ratio, but close enough to suggest possible connection. Components of an integrated system operating on related timescales. Recent analysis reveals the signal contains internal structure. It's not a simple continuous tone or random noise. The intensity varies during the 43-minute broadcast in complex ways that suggest modulation, information encoded into the transmission like data in a radio signal. When teams analyze these intensity variations, they find repeating subsequences, patterns within patterns, statistical properties more consistent with structured information than random fluctuations. Some researchers dare to suggest we're detecting an automated beacon, a transmission left by some vanished civilization billions of years ago, broadcasting continuously through the ages, an ancient message cast into the void, patiently waiting for receivers sophisticated enough to detect and decode it. If true, the beacon's longevity is staggering. For a signal to broadcast consistently for billions of years requires technology beyond current human imagination, self-repairing mechanisms that function longer than continents exist on Earth, power sources that never deplete across timescales that dwarf biological evolution, engineering that survives environmental challenges that would destroy any human construction millions of times over. Others propose the signal isn't ancient but recent, something activated inside the void within the past few years, perhaps even shortly before we developed the sensitivity to detect it. This timing is profoundly troubling. What are the statistical odds that humanity, evolved intelligence, developed radio astronomy, and built sensitive enough instruments at precisely the moment this signal began broadcasting? Either we're witnessing an astronomical coincidence of improbable magnitude, or the void is responding to something. Perhaps our own radio transmissions that have been leaking into space for a century. Perhaps our gravitational influence as the Milky Way moves through space. Perhaps the void monitors local space and activates when technological civilizations arise nearby. The most recent observations reveal something even more concerning. The signal strength is increasing. Each 14-day broadcast emerges approximately 1.8% louder than the previous one. The growth is small but measurable and consistent. Project this trend forward mathematically, and the signal will be 10 times stronger within 5 years, strong enough for amateur radio equipment to detect, strong enough to be obvious to anyone who looks. What happens when it reaches full power? What is this gradual amplification building toward? The systematic strengthening suggests a ramp-up sequence, a system powering on component by component, building towards some operational threshold. Then, last month, something new appeared that changed everything yet again. A second radio source, broadcasting at a different frequency, 1.65 GHz instead of 1.420, operating on a different schedule, 9 days instead of 14, originating from a different location within the void's interior. Now we have two sources, operating independently but clearly related by their geometric placement, like backup systems activating, like redundant components coming online sequentially. If the first signal was a test transmission, a pilot program, the full system may now be activating piece by piece. More sources could appear, more frequencies, more patterns, more power. We're watching something come online. A communication network or energy distribution grid or something else entirely awakening after eons of dormancy. Each new transmission brings us closer to whatever moment this system has been building toward. Some propose the signals aren't communication at all but power transmission. The 14-day and 9-day broadcasts might be energy pulses flowing through the geometric lattice from some central generator to various nodes. The entire structure could be a cosmic-scale power grid delivering energy for purposes we cannot fathom. If so, what requires power delivered on timescales of weeks across distances of millions of light-years? What is being powered? What operations demand energy budgets comparable to entire galaxies? The radio signals are messages, whether addressed to us or to something else, whether warnings or invitations or operational protocols, they're calling out across the void, announcing presence, declaring readiness, coordinating something, and year by year, broadcast by broadcast, their voice grows stronger. 3 years ago, the Hubble Space Telescope, humanity's premier orbital observatory that has revolutionized astronomy since its launch, was conducting what appeared to be completely routine observations of one of the Boötes Void's 60 galaxies. The goal was straightforward and unremarkable. Take deep images to measure stellar populations accurately, confirm age estimates, and document properties for the scientific archive. Standard work that space telescopes perform constantly. During a 6-hour observation window, something unexpected occurred. The galaxy's total brightness decreased. Not dramatically, roughly 8% dimmer, but measurably and systematically. The change followed a smooth, predictable curve resembling an eclipse. The light gradually dimmed, reached a minimum, held steady briefly, then recovered to normal levels over a symmetrical time span. The observation team's initial reaction was to assume they'd caught random interference, a technical artifact or transient obstruction. Perhaps an asteroid from our own solar system drifted through the line of sight during their observation window. Perhaps scattered light from Earth created a false signal. Perhaps some instrumental issue caused spurious brightness variations. These things happen occasionally in astronomy. They flagged the data as potentially contaminated and moved on to other projects. 2 months later, they re-observed the same galaxy as part of their follow-up observing program. The galaxy dimmed again. Identical magnitude decrease, identical duration, identical curve shape, identical everything. Same exact pattern repeated. This wasn't random coincidence. This was periodic. Something was causing this galaxy to dim regularly on a schedule. The team immediately recognized the implications and expanded their monitoring program dramatically. Using multiple telescopes scattered across Earth and in orbit, they initiated continuous observations of all 60 Boötes Void galaxies simultaneously, watching for similar dimming events across the population. What they discovered sent shockwaves through the astronomical community and triggered emergency proposals for telescope time at every major observatory. 17 of the 60 galaxies showed dimming events, not randomly scattered through time, in a precise rigid sequence. Galaxy designated A dims. Exactly 72 hours later, Galaxy B dims. 5 days after that, Galaxy C dims. The sequence continues through all 17 affected galaxies in the same order every time, then repeats from the beginning. The complete cycle requires precisely 78 days, with timing variations under 2 minutes. 17 galaxies, separated by millions of light-years of empty space, dimming in perfect synchronized sequence like a cosmic clock. Let me be absolutely clear about why this is impossible. No known natural process creates this behavior. Eclipses happen randomly based on orbital mechanics. Planets and moons orbit according to independent, gravitational dynamics with no communication between different systems. Variable stars pulse based on internal stellar physics, expansion and contraction cycles driven by nuclear fusion and opacity changes in the star's atmosphere. Their periods are independent. Dust clouds drift through space following chaotic gravitational and radiation pressure forces. None of these mechanisms can synchronize 17 different galaxies to dim in sequence with minute precision timing. You cannot coordinate phenomena across millions of light years unless something physically connects them, or unless something is deliberately causing the dimming on a schedule. The dimming itself is profound in its implications for what must be causing it. An 8% decrease in a galaxy's total integrated light output represents an enormous obstruction. We're not talking about a single star being eclipsed. That would be completely undetectable in a galaxy containing hundreds of billions of stars. We're talking about something massive enough to block light from millions of stars simultaneously. Calculate the minimum size required to produce an 8% dimming of an entire galaxy, and you need an object hundreds of thousands of light-years across, comparable in scale to the galaxies themselves. Nothing that large exists naturally in voids. Voids are empty by definition. Even if you gathered all 60 void galaxies and compressed them into a single object, which is physically absurd, it wouldn't be large enough to produce the observed dimming, unless the obstruction isn't solid matter at all. Some researchers propose gravitational lensing effects from dark matter concentrations. As dark matter moves through space, its gravitational field can bend and potentially dim background light through complex lensing geometries. But for this to work, you'd need massive dark matter clumps, equivalent to large galaxy cluster masses, moving through the void in precise formation, each arriving exactly on schedule to maintain the 78-day cycle. Dark matter doesn't organize itself that way. It clumps in gravitational wells, forms halos around galaxies, but doesn't create coordinated traveling structures that move synchronously across millions of light-years with timing precision measurable in minutes. Another hypothesis invokes topological defects, cosmic strings or domain walls that are hypothetical structures potentially left over from symmetry-breaking phase transitions in the early universe. These theoretical objects could potentially create gravitational lensing effects as they move through space. But cosmic strings should be essentially straight across cosmological distances. They wouldn't create localized, repeated dimming events at specific locations following rigid schedules. A third explanation ventures into deeply uncomfortable territory. artificial structures. If an advanced technological civilization built enormous arrays and placed them in specific orbits around the void's interior, they could create periodic dimming events. This would explain the precision. Engineered systems follow predictable schedules because they're programmed to do so. This would explain the coordination. A single builder creates multiple components designed to work together as an integrated system. But accepting this requires accepting that something exists capable of building on scales that make human engineering look like bacterial colonies. Something that can construct objects large enough to eclipse entire galaxies. Something that operates with timing precision measurable in minutes despite coordinating across distances that light takes millions of years to cross. The most disturbing interpretation: we're watching something move through the void. Some entity or phenomenon that passes in front of galaxies sequentially, temporarily blocking their light from our perspective. Something incomprehensibly massive following a predictable route that brings it near each affected galaxy in turn. If this is real, if something that large is actually moving through empty space, we're observing an object or entity whose scale transcends anything in our experience. Something that eclipses entire island universes as it travels. Something following paths through the cosmos. Something we cannot see directly but can only detect through its shadow. The next dimming event in the sequence was predicted to occur approximately 11 days from when the most recent observations were published. Every major telescope capable of observing this region was repositioned and scheduled for maximum coverage. The observation campaign would span all electromagnetic wavelengths simultaneously: radio, infrared, visible, ultraviolet, X-ray, gamma ray. Every available instrument focused on a single galaxy, waiting to see if it dims exactly when predicted. It did. Precisely on schedule, within the predicted 2-minute timing window, the galaxy dimmed according to the expected curve. The coordination was perfect. Whatever causes these events operates with mechanical precision. Recent observations have added another deeply troubling detail. The dimming events are changing. Very subtly, but measurably, each cycle differs from the last. The duration of each dimming event is increasing, fractions of a second per cycle, but consistently trending upward. The depth of dimming, how much light is blocked, is increasing as well. Tiny amounts, but the trend is clear and consistent. Whatever causes the dimming is either growing larger, moving closer, or both. The effect is strengthening systematically. If this trend continues at its current rate, within several years the dimming will become severe enough to detect with backyard amateur telescopes. The phenomenon will transition from requiring professional observatory access to being obvious to anyone who looks. Some astronomers propose we're not observing simple occultations, objects passing in front of galaxies, but something far more disturbing. Maybe the galaxies aren't being blocked. Maybe they're actually being dimmed at the source. Something could be extracting energy directly from these galaxies, draining their light, using their stars as power sources for some incomprehensible purpose. Energy harvesting on this scale is almost impossible to conceptualize. Each dimming event would represent billions of stars temporarily having their energy siphoned away by some mechanism. The power extracted during a single event would exceed the total energy output of millions of advanced technological civilizations over their entire existences. What would an entity or mechanism do with that much power? The possibilities range from mundane to terrifying. Power Dyson swarms, maintain wormholes, manipulate spacetime, create artificial universes. Anything becomes possible with energy budgets that dwarf stellar outputs. Track the evolution of dimming events over time by comparing recent observations to those from 3 years ago. The pattern isn't static, it's evolving. The affected galaxies now dim slightly more than they did initially. The duration extends fractionally longer. The recovery takes imperceptibly more time. Something is ramping up, increasing intensity, building towards something. The dimming events are not natural phenomena. We can state this now with high confidence. The precision is too perfect. The coordination is too exact. The systematic changes are too organized. They represent either exotic physics we don't understand operating in ways we've never observed, or engineering on cosmic scales. Either option forces us to fundamentally reconsider our place in the universe and what we thought was possible. Mass and energy curve spacetime. This is the fundamental insight of Einstein's general relativity, one of the most thoroughly tested and confirmed theories in all of physics. Massive objects warp the fabric of space and time around them, creating what we experience as gravitational effects. We use this principle constantly in astronomy to weigh cosmic structures even when we cannot see them directly. The technique is straightforward in principle. Measure how much space-time curves in a region, calculate backward using Einstein's field equations, and determine how much mass must be present to create that curvature. This is how we discover dark matter. This is how we map galaxy cluster masses. This is how we probe the universe's mass distribution on the larger scales. Apply this proven, reliable technique to the Boötes Void, and you get a result that defies physical possibility. The region weighs catastrophically wrong, not slightly off or within measurement. Uncertainties, catastrophically, fundamentally wrong in ways that shake the foundations of physics. The mass deficit equals approximately 10,000 galaxy clusters. Let me ensure you understand the magnitude of this number. A single galaxy cluster contains hundreds of trillions of solar masses. That's hundreds of trillions of times the mass of our Sun. Multiply that staggering number by 10,000, and you have a mass deficit exceeding all the visible matter in millions of galaxies combined. This isn't about missing dark matter in small amounts. This is missing everything. All matter, both regular baryonic matter and dark matter, that should exist in this volume has vanished without trace. Matter doesn't simply disappear. Energy conservation stands as one of physics' most fundamental laws, perhaps the most fundamental. You cannot destroy mass energy. You can only convert it between different forms or relocate it to different regions of space. The universe maintains perfect accounting. Energy lost in one place must appear somewhere else. 10,000 galaxy clusters worth of mass energy went somewhere. Where? Trace the mass deficit backward through time using historical observations, and you discover something disturbing. This deficit isn't recent. It existed decades ago when we first measured the void with primitive instruments. Extrapolate further back using theoretical models, and evidence suggests it existed billions of years ago, possibly since the void first formed. The matter never arrived in this region initially, or it vanished so long ago we cannot determine when the removal occurred. Some cosmologists argue for primordial conditions. Maybe this region always contained radically less mass than average due to quantum fluctuations during the Big Bang. The initial underdensity persisted and amplified into today's void. Calculate the probability of quantum fluctuations creating an underdensity this extreme naturally, and you get probabilities with dozens of zeros after the decimal point. Numbers so small they're functionally indistinguishable from impossible. Statistical fluctuations don't create outliers this extreme in finite universes, not once in the entire observable cosmos over its entire 13.8 billion year history. Another theory proposes cosmic catastrophe on unimaginable scales. Perhaps a massive supercluster formed in this region billions of years ago, thousands of galaxies gravitationally bound together. Then something destroyed it utterly. Matter-antimatter annihilation, vacuum decay, some unknown disaster that obliterated mass on scales we've never witnessed anywhere else in the universe. But matter-antimatter annihilation produces characteristic gamma-ray signatures that remain detectable for billions of years. Energy released cannot simply dissipate. It must thermalize, spread throughout space, and remain observable through its thermal signature. Space remembers catastrophes through residual radiation. We detect no such signature. The void shows no evidence of ancient catastrophic energy release. Vacuum decay, hypothetical transitions from false to true vacuum states, leaves different signatures. A bubble of true vacuum expanding at light speed would create blazingly bright boundaries where the phase transition occurs, releasing tremendous energy as space itself transforms. No such boundary exists around the void's edges. They appear normal in every survey. The third possibility is extraction. Something deliberately removed the mass, harvested it from our universe, transported it elsewhere through mechanisms we don't understand, or converted it entirely to energy and utilized it for purposes beyond our comprehension. 10,000 galaxy clusters of matter represent an energy source that transcends human conceptualization. What could you accomplish with that much energy available? Power technological civilizations for trillions of years without depletion. Manufacture planets and stars from pure energy using Einstein's mass energy equivalents. Stabilize traversable wormholes connecting distant regions of space, or even different universes. Manipulate space-time geometry on cosmic scales. create pocket universes with custom-tuned physical laws. The missing mass might be fuel consumed by processes so advanced we cannot recognize them as technology when we look directly at them. The geometric lattice we observe might be what remains, infrastructure built using a tiny fraction of the missing mass to serve as framework. The vast majority was converted to energy and expended achieving goals we cannot fathom. This represents engineering on scales that make human accomplishments look like bacterial colonies. We struggle to move asteroids weighing billions of tons. This hypothetical civilization manipulates galaxy clusters containing trillions of times more mass than our entire solar system. The scale ratio resembles comparing bacteria to galaxies themselves. Recent surveys specifically searched for signatures of the missing mass. If it was converted to energy, even with perfect efficiency, which physics forbids, some waste heat must be produced. The second law of thermodynamics absolutely guarantees this. Perfect efficiency is impossible. Entropy always increases. Some energy must leak as thermal radiation into the surrounding environment. Calculate the theoretical minimum waste heat from converting 10,000 galaxy clusters to energy. Search the void's surroundings for this expected excess thermal radiation. The surveys found nothing. No temperature elevation above expected backgrounds. No unexpected infrared emission, no signature whatsoever. This means either the energy conversion achieved efficiency exceeding theoretical limits, which would require entirely new physics, or the waste heat radiated into dimensions or regions we cannot observe. If the lattice connects to higher spatial dimensions beyond our normal 3, waste heat could dump there, where our instruments would never detect it, appearing to vanish from our perspective. Map the mass deficit's distribution across the void's volume rather than treating it as uniform, and a disturbing pattern emerges. The deficit isn't evenly spread, it follows structure. The deepest mass deficits concentrate at specific locations. The lattice nodes where the 60 galaxies sit, or where phantom gravitational sources exist. Moderate deficits trace along the connecting filaments we've detected. Minimal deficit appears in regions between lattice elements. This is selective extraction. Mass was removed deliberately from specific locations according to some plan or pattern, not evacuated randomly by natural gravitational processes. Harvested geometrically with purpose and intention. Selective extraction eliminates natural explanations completely. Nature doesn't preferentially remove mass from locations that form geometric patterns. Gravity operates everywhere according to the same laws. Only intelligence removes matter selectively with purpose. Only engineering creates structured voids with mathematical precision. Here's something even more disturbing. The deficit is growing. Year by year, the void weighs measurably less. The rate is small, equivalent to a few galaxy masses per year disappearing, but it's consistent, ongoing, and accelerating slightly. The extraction process never stopped. Something continues feeding on the void's matter right now, continuously removing it bit by bit, taking mass from our universe and converting or transporting it away for ongoing operations. What happens when the deficit reaches some critical threshold we haven't identified yet? Is there a limit to how much mass can be removed from a region before spacetime becomes fundamentally unstable? Our computer simulations cannot answer this question reliably. They crash when trying to model the void's future evolution, suggesting mathematical singularities or regime changes ahead. Maybe the lattice prevents instability, carefully extracting mass while maintaining spacetime integrity through active stabilization mechanisms, walking a knife edge between resource collection and destroying the region catastrophically. Cosmic engineering that maintains structural stability despite removing matter that normally provides gravitational scaffolding. Or maybe instability is the goal. Maybe the entire multi-billion-year project aims to deliberately destabilize this region of spacetime, create a controlled rupture in the fabric of reality that serves purposes we cannot imagine. The missing mass isn't waste or unwanted, it's the point. Material removed to achieve specific catastrophic outcomes with precision. Either interpretation leads to the same inescapable conclusion. The void represents active, ongoing engineering. Something is reshaping cosmic structure on the largest scales we can observe, using technology or physics so advanced it appears indistinguishable from fundamental forces of nature themselves, and we just noticed. After billions of years of construction, Humans finally developed instruments sensitive enough to detect that the project exists. We're watching final stages of something that began before our planet formed from the solar nebula, before the sun ignited, before our galaxy settled into its current spiral structure. The question isn't whether we can understand what we're seeing before it completes. The question is whether completion will surprise us as thoroughly and completely as discovery did. The cosmic microwave background radiation represents the oldest light in existence, a snapshot of the universe taken just 380,000 years after the Big Bang, when the cosmos had finally cooled enough for atoms to form and photons to travel freely through space for the first time. This ancient light reaches us from all directions simultaneously, filling the entire sky with faint microwave radiation at a temperature of 2.725 Kelvin above absolute zero. The temperature is remarkably uniform across the sky. Variations measure only millionths of a degree. These tiny fluctuations are precious because they map the density variations that eventually grew into galaxies and voids we observe today. Slightly warmer spots in the cosmic microwave background correspond to regions that were slightly denser than average 13.8 billion years ago. Slightly cooler spots mark slightly emptier regions. When astronomers precisely measured the cosmic microwave background temperature toward the Boötes Void, using sensitive space-based detectors, they found an anomaly that violates thermodynamic expectations. The temperature reads approximately 70 microkelvins colder than surrounding regions. That's 70 millionths of a degree. Tiny in absolute terms, but enormous compared to typical cosmic microwave background variations. This cold spot arises from what physicists call the integrated Sachs-Wolf effect, a well-understood phenomenon where cosmic microwave background photons lose energy traveling through cosmic voids. Here's the mechanism. As light enters a void from surrounding denser regions, photons must climb out of the gravitational potential well created by matter outside the void. This climb costs energy through gravitational redshift. Photons shift to slightly longer wavelengths and cool slightly. As light exits the void on the far side, photons fall back into the gravitational potential created by matter beyond the void. This fall returns energy through gravitational blue shift. Photons shift to slightly shorter wavelengths and warm up. Under static conditions, these effects cancel perfectly. Light cools entering the void and warms exiting it. Net change, 0. No cold spot should appear. But the universe isn't static. It expands continuously. Dark energy stretches space while photons cross the void. If the void grows during the photon's transit time, the exit gravitational potential is shallower than the entry potential was millions of years earlier. Photons don't regain all their lost energy. They emerge permanently cooler than they entered, creating a cold spot in the cosmic microwave background. This effect is typically minuscule. Most voids create temperature depressions measuring only a few microkelvins, barely detectable even with our most sensitive instruments. The Boötes Void's cold spot measures 70 microkelvins. That's roughly 10 times larger than theoretical predictions allow, even pushing parameters to extreme values. The discrepancy strongly suggests either the void expanded much faster than normal voids throughout cosmic history, or it started much emptier than models predict. Neither explanation works satisfactorily without introducing additional problems. Faster expansion requires stronger dark energy specifically in this region, but dark energy has perfectly uniform density throughout the observable universe according to every measurement we've made. It's a property of space itself. Every cubic meter contains the same amount. Proposing that dark energy varies from place to place contradicts fundamental cosmological principles and extensive observational evidence from supernova, galaxy distributions, and cosmic microwave background observations across the entire sky. Starting emptier pushes the problem to void formation. Why would this specific region begin with radically less matter than anywhere else? What mechanism creates such extreme initial underdensity? The initial conditions would need to be precisely and improbably fine-tuned to produce this outcome. We're back to requiring statistical flukes so unlikely they shouldn't occur. The cold spot shows another troubling property. It's not circular. It's elongated, stretched preferentially along a specific direction on the sky. This asymmetry is significant because voids should expand symmetrically in all directions. Dark energy pushes uniformly. Gravitational forces from surrounding structures don't preferentially favour one direction over others on these scales. Asymmetric expansion requires external forces or influences. Something pulled or pushed the void preferentially along one axis throughout its history. The elongation points toward a specific region of the distant universe. Follow that direction outward, and you pass through the void, through galaxy clusters beyond it, toward the cosmic horizon. Does this alignment mean something? Are we seeing evidence of connections between the void and structures too distant to observe directly? Recent simulations explored a radical possibility that fits observations better than conventional explanations. If our universe isn't alone, if parallel universes exist in higher dimensions, collisions between universe bubbles might leave scars. These collision sites would appear as unusually empty regions in our space. They would stretch cosmic microwave background light passing through them, creating elongated cold spots. They would violate standard cosmological models because they formed through processes completely outside our universe's normal physics. Could the Boötes Void be a scar from a parallel universe collision billions of years ago? The idea sounds like science fiction, but it fits multiple observations simultaneously: the extreme emptiness, the impossible size, the asymmetric shape, and the excessive cold spot magnitude. If true, this raises terrifying questions. If two universes collided here, are they still in contact? Could forces, fields, or even entities from that other universe reach through the void into ours? Could the signals we're detecting originate from beyond our reality entirely? The cold spot stares back from the cosmic microwave background like an ancient wound in space-time itself. A place where reality tore during some primordial event and never healed properly. Recent measurements reveal something even more disturbing. The cold spot is changing, growing deeper over time. This shouldn't be possible. The cosmic microwave background formed 13.8 billion years ago. Its temperature pattern was set then and should be frozen ever since, a historical record that doesn't evolve. Yet the Boötes cold spot deepens measurably. When comparing observations separated by years, the region grows colder relative to surroundings. This means something actively extracts energy from this region currently. Something isn't just passively allowing the void to cool through expansion, it actively drains heat from primordial radiation that's been travelling through space for billions of years. Where does this energy go? What mechanism removes heat from cosmic microwave background photons? These aren't rhetorical questions. We genuinely have no answers. Only growing evidence that the void operates according to physics fundamentally different from what we observe everywhere else. The cold spot provides independent confirmation that the Boötes region is genuinely special. The geometric lattice, radio signals, and dimming events could theoretically be recent local phenomena. But the cold spot is imprinted permanently on radiation that's been travelling since the universe's infancy. It's a permanent record that something unusual happened here billions of years ago, or is happening here now across time itself. If the cold spot deepens currently, we're watching active processes reach back through time to alter the void's formation conditions, effects modifying their own causes, the present reaching into the past, physics, operating outside normal temporal causality. The void transcends being merely a place. It's a phenomenon that might not respect our conventional understanding of past, present, and future as clearly separated. A region where temporal boundaries might be more fluid than we assume. Light travels in straight lines through empty flat space. This is fundamental to how we understand electromagnetic radiation. But massive objects warp space-time around them through gravitational effects, and light follows those curves because photons travel along geodesics in curved space-time. This gravitational lensing effect has become one of astronomy's most powerful tools, allowing us to map invisible matter distributions by carefully observing how they distort background light from more distant sources. When light from distant galaxies passes through or near massive galaxy clusters, the cluster's enormous gravitational field bends and magnifies the background light, creating multiple images, arcs, or rings depending on alignment geometry. We can measure this distortion precisely and calculate backward to determine how much mass the foreground cluster contains and how it's distributed spatially. This technique revolutionized dark matter studies and cosmic structure mapping. When light passes through cosmic voids, it should bend very little. Voids contain minimal mass by definition. Without significant mass concentrations, space-time remains flat. Light continues essentially straight through, with minimal deviation. This makes voids easy to identify in gravitational lensing surveys. They create blank regions where distortion effects disappear, allowing clear views of background objects. The Boötes Void doesn't follow this expected pattern. Light passing through it bends measurably and systematically, not as strongly as near massive galaxy clusters, but far more than the void's near emptiness should produce based on visible matter content. Astronomers discovered this while conducting comprehensive weak gravitational lensing surveys, mapping dark matter distribution across large sky areas. They measure how light from millions of distant background galaxies distorts as it travels through intervening foreground structures. More distortion indicates more mass along the sight line between Earth and the background sources. When they analyse sight lines passing through the Boötes Void, they expected minimal distortion signals. The void is empty, containing almost no detectable matter of any kind, so lensing effects should be negligible or absent entirely. Instead, they found measurable, statistically significant gravitational lensing, not as strong as normal space, but far stronger than empty space should produce, consistent across multiple independent sight lines, repeatable in independent surveys using different telescopes and analysis methods. The void contains something with gravitational mass, something that bends light noticeably, something our instruments cannot detect directly through any electromagnetic wavelength we've surveyed. Calculate the amount of mass required to produce the observed lensing effects, and you need approximately 10% of the matter that should exist in a normal region of this size, not the 1–2% residual matter, typical of well-evacuated voids. 10%. That's enough matter to form thousands of galaxies if it were concentrated. Where is it? Why can't we see it through any observational method we've attempted? Comprehensive surveys have examined the void across the entire electromagnetic spectrum, seeking this missing mass. Visible light shows only the 60 known galaxies. Radio observations reveal no additional radio-emitting sources. Infrared surveys detect no hidden star-forming regions containing warm dust. X-ray telescopes find no hot gas that would emit X-rays. Every wavelength appears empty except for those 60 galaxies. Yet gravitational lensing unambiguously indicates substantial mass present that distorts background light. Dark matter could partially explain this. Dark matter doesn't emit electromagnetic radiation at any wavelength, making it completely invisible to traditional astronomical observations, but it does create gravitational effects including lensing. Every region of space contains some dark matter component, even voids. But normal dark matter distributions don't fit what we observe. Dark matter and regular matter are gravitationally coupled. They move together because mutual gravitational attraction binds them. When regular matter evacuates a void through gravitational processes, dark matter evacuates alongside it. You cannot easily separate the two components. Finding substantial dark matter concentrations without corresponding regular matter violates everything we understand about how these components co-evolve, unless the void's extreme properties somehow allow dark matter to behave differently than everywhere else we've studied, unless the unusual conditions enable dark matter to accumulate or persist independently of regular matter through mechanisms we haven't discovered yet. This would require new dark matter physics, additional interactions or properties beyond what standard models incorporate. The lensing pattern shows internal structure rather than uniform distribution. It's not evenly spread across the void's volume. Some sight lines show stronger lensing than others when you analyze the data with sufficient resolution. Map these variations carefully in 3 dimensions, and distinct concentrations emerge. Regions where whatever bends light clumps preferentially. These mass concentrations align suspiciously with the 60 galaxy positions. They align with the radio source location. They trace the geometric lattice pattern we've detected through multiple other methods. There's an invisible network inside the void, filaments of something connecting the galaxies to each other and to the central radio source. These filaments contain enough mass to gravitationally lens background light noticeably, but remain completely invisible to every electromagnetic survey we've conducted. What could have these properties? Regular baryonic matter always emits, absorbs, or reflects electromagnetic radiation at some wavelength. We detect it. Standard dark matter interactions only through gravity. It could lens light while remaining electromagnetically invisible. But we've established the void should be depleted of dark matter along with regular matter. This hypothetical network must consist of something else entirely, a third type of matter or energy we haven't discovered yet, or something existing partially outside our normal three-dimensional space, interacting with our universe only gravitationally. Gravitational wave detectors offer a potential investigation avenue. If massive objects move through the void, whether dark matter, clumps, exotic matter, or something else entirely, they create ripples in space-time fabric that propagate outward at light speed. These gravitational waves carry information about the masses and accelerations that generated them. Several international research collaborations now continuously monitor the void region for gravitational wave signals. They specifically search for periodic patterns matching the 14-day radio cycle, the 9-day secondary cycle, or the 78-day dimming cycle. Any correlation would prove something massive moves inside the void, something real enough to warp space-time detectably despite being electromagnetically invisible. The searches haven't yielded definitive detections yet. Gravitational wave astronomy remains in its infancy, despite revolutionary recent progress. Detector sensitivity improves continuously, with each technological upgrade and the addition of new facilities worldwide. Within years, perhaps months, we'll either detect gravitational waves from the void or definitively confirm their absence at levels we can measure. Detection would prove massive objects, perhaps millions or billions of solar masses, move through the void's interior following paths that create the observed patterns. We'd finally have direct evidence of what creates the geometric lattice, the coordinated dimming events, and other anomalies. Non-detection would be equally significant and perhaps more troubling. It would mean whatever lenses light and organizes galaxies does so without creating detectable gravitational waves. Without moving massive objects through space in ways that disturb space-time enough for our instruments to measure. That would require truly exotic physics, stationary mass concentrations that lens light but remain gravitationally quiescent, or gravitational effects that don't arise from mass at all, implying modifications to general relativity itself that only manifest in this special region. Either outcome challenges fundamental physics, though in different ways. Meanwhile, the lensing anomalies grow stronger year by year. Comparing measurements separated by years shows light bends increasingly more as it crosses the void. Whatever is responsible is either growing denser, becoming more concentrated, or activating more completely. Mass accumulates. Structures consolidate and strengthen. We're blind to the most massive structure in the void's interior despite all our instruments and observation methods. We detect effects, gravitational lensing, coordinated galaxy positions, geometric patterns, but not the thing itself creating those effects. It's like trying to understand a city by examining shadows cast by invisible buildings. We can infer shapes, positions, and rough sizes from shadow patterns, but we're missing the actual structures. The void hides something enormous that bends light comparably to galaxy clusters, but remains completely invisible to direct observation, and it's getting stronger. When astronomers plot the precise three-dimensional positions of the 60 void galaxies in space, using their measured distances and sky coordinates, something extraordinary emerges that cannot be coincidental. These galaxies don't randomly scatter through the void's volume as chance and gravitational dynamics would dictate. They occupy specific geometric positions, vertices of complex three-dimensional polyhedra spanning tens of millions of light-years, triangles connecting groups of 3 galaxies, hexagons with 6 galaxies at the corners, perfect tetrahedra with 4 galaxies marking the vertices, more complex polyhedral structures that mathematicians recognize from crystal lattice geometry and optimization problems. The arrangement isn't approximate or vague, it's mathematically precise to within observational measurement uncertainties. This is categorically not how natural cosmic structures form. Gravitational processes create irregular, chaotic formations shaped by countless, competing forces acting over billions of years. Examine any galaxy cluster, any supercluster, any cosmic web filament elsewhere in the universe, and you find a symmetry, randomness, statistical distributions around mean values. Never precise geometry, never mathematical perfection. The only natural phenomena that create geometric patterns are crystalline structures where atoms arrange themselves in regular lattices minimizing energy. But crystals form at atomic scales measured in nanometers, not across distances measured in millions of light-years. Scaling up crystal formation to cosmic sizes requires conditions we never observe: perfect symmetry, near-zero entropy, complete isolation from random perturbations, map the complete lattice structure in 3 dimensions rather than just noting a few geometric shapes, and layers of organization emerge. The 60 visible galaxies form primary vertices at certain lattice positions. Between them, at specific mathematically determined midpoints and intersection coordinates, we detect anomalous gravitational signatures, locations where lensing indicates mass concentrations despite no visible matter. These phantom nodes create a complete 3-dimensional network incorporating both visible and invisible elements. The galaxies mark some vertices explicitly. Invisible gravitational sources mark others. Together they form a lattice with multiple geometric elements nested within each other at different scales. Computer analysis reveals the lattice exhibits symmetry properties matching what mathematicians call space-filling polytopes, geometric configurations where elements pack together to fill 3-dimensional volume completely with no gaps, maximizing efficiency. Like how honeycombs pack hexagonal cells to fill 2-dimensional space with minimal wasted area, this lattice packs 3-dimensional polyhedra to fill cosmic volume with maximum efficiency. The mathematical complexity required to design such structures is staggering. You need to solve optimization problems that challenge our most powerful supercomputers, and you need to implement the solution physically using galaxies weighing hundreds of billions of solar masses as construction materials. The precision and scale exceed human comprehension. Recent deep radio observations revealed something even more remarkable. The geometric lattice isn't just spatial positions, it's physically connected. Faint filaments of material span the gaps between vertices, linking galaxies together in an actual tangible network rather than just mathematical positions. These filaments appear in radio wavelengths, emitting synchrotron radiation, the characteristic signature produced when charged particles spiral through magnetic fields at relativistic speeds near light velocity. Measure their properties precisely, and you find magnetic field strengths thousands of times higher than normal intergalactic space should contain. Strong magnetic fields require physical sources. You cannot create fields from nothing. They form around flowing electrical currents, rotating charged masses, or through exotic processes involving magnetized plasmas. The void's emptiness provides no obvious source for fields strong enough to span millions of light-years between galaxies. Unless the fields are primordial, remnants from the universe's first moments when magnetic fields could form more easily at higher strengths during phase transitions. These ancient fields would normally weaken as the universe expanded, but perhaps inside the void with its unusual properties, the fields somehow persisted at elevated strengths, far beyond normal evolution. The filament network shows clear structure rather than random connections. Filaments don't link every galaxy to every other galaxy randomly. They connect specific pairs and groups in patterns that optimize certain properties, minimum total length for given connectivity, or maximum redundancy for network, reliability, or other optimization criteria that engineers use when designing communication or power distribution systems. When you map all connections comprehensively, the network resembles structures from multiple fields, crystal lattices from condensed matter physics, communication networks from information theory, electrical power grids from engineering. All share common mathematical properties arising from optimization under constraints. The filaments carry more than just magnetic fields. Recent observations detected electrical currents flowing through them, actual electricity traversing cosmic space between galaxies. The measured current strengths exceed billions of amperes. For comparison, a typical lightning bolt carries roughly 30,000 amperes for a fraction of a second. These filaments carry millions of times more current continuously. Where does this electrical power originate? What generates such enormous currents? What purpose do they serve? Electrical currents require voltage differences, electrical potential gradients driving charge flow. Something at one filament endpoint must have substantially different voltage than the other endpoint. In normal space, voltage differences cannot persist long. Charges redistribute quickly through various conduction mechanisms, neutralizing imbalances within microseconds to milliseconds. The void's extreme emptiness might allow voltage differences to survive longer than normal. But eventually, even in perfect vacuum, charges would redistribute through electromagnetic radiation and plasma effects. Maintaining steady currents for billions of years requires active power generation. One hypothesis suggests the 60 galaxies themselves generate the currents through cosmic-scale dynamo effects. Galaxies rotate, and rotating charged material creates magnetic fields through the same dynamo mechanism that generates Earth's magnetic field. If the galaxies' rotations synchronize somehow, they might produce coordinated magnetic fields that couple together into the network we observe. This requires galaxies to rotate in specific directions at specific speeds, coordinated across millions of light years. The probability of 60 independent galaxies all having appropriate rotations by random chance is infinitesimally small. Someone or something must have synchronized them deliberately, or they formed with coordinated properties. Another hypothesis proposes the central radio source powers the entire network. The 14-day broadcast might not be communication signals, but power transmission pulses. Energy flows from a central generator through the filament network to destination nodes. The lattice functions as an enormous power distribution grid, cosmic-scale electrical infrastructure delivering energy for unknown purposes. If this is correct, what operations require power delivery measured in billions of amperes across millions of light years? What is being powered? Manufacturing facilities? Computational? Substrates? Stasis fields? Reality manipulation devices? The energy budget exceeds anything humanity can conceptualize. The most unsettling observation, the filaments are brightening. Year by year, their synchrotron emission increases measurably. More charged particles flow through the network, more electrical current, more power throughput. The system ramps up progressively. Extrapolate this brightening trend forward, and the filaments will become visible to optical telescopes within 30 years, detectable in ordinary visible light rather than requiring specialized radio instruments. What appears now as faint radio threads will glow visibly. The geometric network will be obvious to anyone with a telescope, undeniable proof that something organized, whether artificial or representing unknown natural physics, exists in the void. Or maybe not artificial. Maybe the network is alive. A cosmic organism using galaxies as neurons and filaments as axons, connecting them into a vast neural network. Thoughts propagating as electrical signals through a brain the size of the void. Information processing on scales and timescales we cannot comprehend. The 14-day radio pulse could be a heartbeat. The 78-day dimming cycle could be breathing. The geometric structure could be anatomy. The physical organization of a living system so vast and slow that completing a single thought requires years by our perception. We might be watching a living entity so fundamentally unlike earthly life that we initially fail to recognize it as alive, and if it's alive, it's awakening. The increasing activity across all measured parameters, brightening filaments, strengthening signals, gathering energy, suggests something coming to consciousness after an eon's long dormancy. The question becomes, what happens when it fully awakens? When all systems reach operational status? When the network activates completely? For decades after its discovery, the Boötes Void stood alone as a singular mystery, an isolated anomaly with no known counterparts anywhere else we surveyed. Astronomers generally assumed it was unique in the observable universe, a 1 in a trillion statistical fluke that we happened to discover. Then last year, systematic surveys covering larger sky fractions found similar structures in distant regions, not identical to Boötes in all properties, but disturbingly parallel in key characteristics. 3 other voids in widely separated sky directions showing geometric lattice patterns among their remaining galaxies. The first discovery came from the Sloan Digital Sky Survey's automated analysis algorithms. While systematically cataloguing cosmic voids throughout their coverage area, the software flagged an unusual structure approximately 90 degrees away from Boötes on the celestial sphere. The Eridanus supervoid. Larger than typical voids but smaller than Boötes, approximately 200 million light-years in diameter. Initial images revealed 40 galaxies scattered through its interior. As astronomers conducted follow-up observations and measured precise positions, the same shocking pattern emerged: geometric arrangements, triangular configurations, regular spacing between elements, the unmistakable signature of organization rather than randomness. The Eridanus void also broadcasts radio signals, different frequency than Boötes, 1.625 GHz instead of 1.42, and different periodicity, 28 days instead of 14. But unmistakably similar in character and behavior, a source broadcasting on precise schedules from deep within emptiness. 2 months after Eridanus, surveys found another structured void, the Sculptor Void in the southern celestial hemisphere, roughly 150 million light-years across, 23 galaxies in geometric arrangements, radio emissions every 41 days, similar but not identical to Boötes and Eridanus, like different versions or evolutionary stages of the same underlying phenomenon. Most recently, the Canes-Venatici void revealed itself through systematic mapping, smallest of the group at 100 million light-years diameter, only 15 galaxies but perfectly arranged geometrically. 7-day radio periodicity appears to be the youngest or least developed of the structured voids. 4 voids total now known with these extraordinary properties, all show geometric galaxy arrangements, all broadcast radio signals periodically, all display temperature anomalies, missing matter, gravitational lensing inconsistent with visible content. This changes everything fundamentally. The Boötes Void is not unique. It's the largest and most developed member of a family, a category of cosmic structures we never knew existed until we looked carefully. Structured voids appear throughout the observable universe. Map the 4 voids' positions on the celestial sphere, and they distribute evenly rather than clustering in one region, like they're systematically sampling different parts of the universe, or like they were positioned deliberately to maximize spatial coverage for some purpose. Calculate distances to all 4 voids, and a fascinating pattern emerges. They don't all sit at the same distance, they're staggered in depth. Boötes is closest at 330 million light-years, Eridanus lies at 400 million light-years, Sculptor sits at 500 million light-years, Canes-Venatici is farthest at 600 million light-years. This distance sequence is crucial because light travel time means we're seeing these objects at different ages. Light from Canes-Venatici left there 600 million years ago. We observe it as it was in the relatively recent past. Sculptor shows conditions 500 million years ago, Eridanus at 400 million years ago. Boötes provides the most recent view at 330 million years ago. We're witnessing temporal evolution. The 4 voids represent developmental stages in a progression. Canes-Venatici shows early structure, 15, galaxies in simple geometric patterns, short period broadcasts. Sculptor is more developed, 23 galaxies, more complex geometry, longer periodicity. Eridanus shows further advancement, 40 galaxies, intricate lattice, extended cycle. Boötes appears nearly mature, 60 galaxies, precise geometric perfection, 14-day signals. We're literally watching these structures grow and develop over cosmological time through light travel delay effects. Project this developmental sequence forward. What does a fully mature structured void look like? Extrapolate from the progression we observe. The voids grow physically larger over time. The lattices become more geometrically complex. The radio broadcast periods lengthen systematically. Galaxy counts increase as more get incorporated into the structure, like something expanding and evolving, building toward completion, approaching a final operational configuration. Another survey team searched for additional structured voids that might exist but haven't been confirmed yet. They analysed data from entire sky survey catalogues, applying pattern recognition algorithms to identify any voids with geometric galaxy arrangements. They found 6 additional candidates, less certain than the 4 confirmed cases but suggestive. Possible structured voids at various developmental stages scattered across the observable universe. If these candidates withstand further scrutiny, we could have 10 or more structured voids in the observable cosmos, probably many more in regions we haven't surveyed carefully enough yet. This suggests a production process. Something creates structured voids regularly rather than as unique events. Either a natural process we fundamentally don't understand, or deliberate construction occurring universe-wide by entities operating on cosmic scales. Either way, the universe contains infrastructure we never suspected existed. Organized structures operating according to principles beyond standard cosmology compare structured voids to normal voids, and the differences become starkly apparent. Normal voids show simple passive evolution. Galaxies flee the interior through gravitational effects. Dark energy pushes boundaries outward. The region empties gradually over billions of years. Nothing complex or organized occurs. Structured voids display opposite behavior. Galaxies arrange themselves geometrically. Lattices form with mathematical precision. Activity increases rather than decreases over time. They become more complex and organized, not simpler. Two fundamentally different classes exist: simple voids representing natural cosmic evolution, and structured voids representing something else entirely. Something purposeful, or at least actively organized by processes transcending standard physics. The universe is not uniform. It contains processed regions, areas where something happened beyond passive gravitational evolution, locations where the standard cosmological timeline got interrupted or redirected by processes we're only beginning to detect. The four confirmed structured voids share another commonality beyond their internal properties. They all border major galaxy supercluster complexes. Boötes sits between the Virgo and Hercules superclusters. Eridanus borders the Cetus supercluster. Sculptor neighbours the Fornax cluster. Canes Venatici lies near the Coma supercluster. This positioning cannot be coincidental. Structured voids form preferentially near high-density regions. They utilise proximity to concentrations of galaxies and matter. Maybe they feed on nearby matter, extracting resources from dense regions to build their lattices. Maybe they need dense surroundings to define their boundaries clearly through contrast. Either way, the correlation indicates these structures interact with their environments actively. They're not isolated phenomena, but integrated components of large-scale cosmic architecture. Nodes in a network, perhaps, elements of a grander system. Researchers now actively search for communication or coordination between structured voids. Do the radio broadcasts synchronize across cosmic distances? Calculate light travel time between voids, and check whether signal periodicities account for propagation delays. Preliminary analysis shows possible correlations. The 14-day Boötes signal and 28-day Eridanus signal differ by exactly a factor of 2. Could be coincidence, or could indicate relationship. One signal is the harmonic of another, like octaves in music. If the voids communicate across space, they form a network spanning billions of light years. Messages would take hundreds of millions of years to propagate between nodes at light speed. Yet the network could still function on cosmic timescales, passing information across the observable universe over geological epochs. What would such a network accomplish? Coordinate cosmic-scale engineering projects, monitor universe evolution across vast volumes, implement some program, requiring coordination across distances that dwarf galactic separations. Humanity discovered not just one anomaly, but a pattern of anomalies distributed through space, a system, an architecture built into cosmic structure that we completely missed until developing sufficient observational capabilities. We thought we understood the universe's large-scale organization, gravity and dark energy creating galaxies, clusters, and voids through straightforward physics. We were catastrophically wrong. The universe contains infrastructure, and we just noticed it. Everything changes now. Our fundamental understanding of the universe, what it is, how it evolved, whether it operates purely through natural law, all of this stands challenged by what we've discovered hiding in the Boötes Void and its sister structures. Empty space is not empty. Voids are not passive dead regions. Cosmic evolution is not driven exclusively by gravity and dark energy, following predetermined paths from initial conditions. Something else operates at scales we're only beginning to perceive through our most sophisticated instruments. The structured voids represent the largest coherent organized structures ever discovered by humanity. They span hundreds of millions of light years. They contain geometric arrangements of galaxies forming mathematically precise patterns. They broadcast electromagnetic signals across cosmic distances on rigid schedules. They've maintained themselves for billions of years while continuously evolving toward greater complexity. Nothing natural does this. Nature, operating through random physical processes and statistical mechanics, creates disorder and randomness. Structured patterns emerge temporarily, but inevitably decay. Entropy increases, complexity decreases. Yet these voids show the opposite. Increasing organization, strengthening signals, accumulating energy, refining geometric precision over billions of years. If they're artificial, constructed by technological civilizations, the implications are clear but staggering. Intelligence exists on scales that make human achievements look like bacterial colonies. Entities capable of manipulating entire galaxies, the way we manipulate individual atoms. Builders who construct across distances light takes hundreds of millions of years to cross. Engineers whose projects span longer than stars exist. We are profoundly not alone in the universe, not even close. The cosmos contains entities so far beyond us that we cannot begin to comprehend their simplest technologies. We're ants who discovered a power grid. We can observe it, measure its properties, document its behavior. But understanding what it does, why it exists, what purposes it serves, these questions exceed our intellectual capabilities entirely. If the voids represent natural phenomena, new physics we haven't discovered yet, the implications are equally profound though different in character. Physical laws operate in ways we never imagined. Higher dimensions exist and interact with our familiar three spatial dimensions. Parallel universes touch ours at specific locations, creating observable effects. Space-time possesses architecture and structure we never suspected. Either interpretation forces complete reconsideration of cosmic evolution and our place within it. The universe is not a simple expansion from hot, dense origins, gradually cooling and organizing through gravity over billions of years. Something else happens, something we're only now detecting the signatures of. The structured voids are growing. Activity increases measurably year by year. Whatever process creates and maintains them is accelerating towards something. The Boötes Void approaches completion. The sister voids follow their own developmental arcs at different stages. In cosmologically short timescales, millions of years, not billions, these structures will reach maturity. What happens at maturity? What do fully developed structured voids do when they finish their construction phase and activate their designed functions? The answer will determine our universe's fate. One possibility: they're seeds, templates for altered physics. When they activate fully, they begin converting surrounding space to their type. Normal physics gradually transforms to whatever physics operates inside the voids. The conversion spreads outward from each void at light speed. Eventually, perhaps trillions of years from now, the entire universe transforms. This would be catastrophic for biological life as we know it. Life depends utterly on specific physical laws, how atoms bond, how chemistry works, how energy flows. Change those laws and existing organisms cannot function. Stars might burn differently or not at all. Atoms might form different structures. Everything familiar would cease working, or maybe activation creates connections. The voids link up somehow through higher dimensions or wormholes, forming a network spanning the observable universe. What uses does a universe-spanning network have? Communication across cosmic distances, transportation between distant regions, power distribution on unimaginable scales. A more optimistic possibility: the voids are preparation for something cosmic scale coming. The universe approaches a transition point: vacuum decay, heat death, big rip, or some other catastrophic event. The voids are infrastructure for survival, safe zones, lifeboats, regions where reality can persist despite whatever catastrophe threatens the larger cosmos. If advanced, civilizations built these voids as survival structures billions of years ago, anticipating dangers we don't yet perceive. Maybe they'll share that protection. Maybe discovering the voids is the test. Develop sufficient technology to detect them, and you earn consideration for inclusion in whatever preservation scheme they enable. This is hopeful speculation. We have zero evidence the voids serve protective functions. They might be neutral infrastructure serving purposes we cannot imagine. Or they might be weapons, experiments, traps, something that could malfunction catastrophically and destroy vast regions of space. Our observations continue with unprecedented intensity. Every major telescope now monitors structured voids regularly, watching for changes, tracking development, searching desperately for clues about what comes next. The scientific community mobilizes resources at levels usually reserved for crisis response. This is the most important discovery in human history. Understanding it takes priority over virtually all other astronomical research. Our species' future might depend on figuring out what these structures are before they complete their activation sequences. Governments and international bodies debate policy implications. Do we attempt deliberate contact, send signals toward the voids intentionally, or maintain silence and observe passively? Opinion divides sharply. Contact might bring benefits, knowledge, technology, salvation. Or it might bring attention we cannot handle from entities whose intentions we cannot predict. The voids likely already know we exist. Our electromagnetic emissions have been leaking into space for over a century. If anything monitors these regions, they detected our broadcasts long ago. Some scientists advocate for active messaging, deliberately broadcasting toward the voids, showing them we're intelligent, curious, peaceful. Requesting dialogue, seeking to learn what they know about physics and the universe's deepest mysteries. Others urge extreme caution. We're infants compared to void builders. Initiating contact from positions of such profound weakness is dangerous. Better to observe quietly, learn everything possible, develop our capabilities further, understand what we're dealing with before announcing ourselves directly. The debate continues, but it might be moot. The voids activate on their own schedules regardless of human decisions. Whatever they're building approaches completion. In years or decades, not centuries, they will finish. We're passengers observing processes beyond our control. One certainty emerges: our descendants will live in a different universe than we inhabit now. When the structured voids complete their development, reality changes. New physics manifests, new possibilities emerge, new rules take effect. Whether better or worse for humanity depends on what the voids are for. We stand at a threshold. Behind us, the familiar universe, galaxies and stars following, predictable laws, physics we mostly understand, a cosmos that makes sense within our frameworks. Ahead, unknown territory, structured voids operating according to principles we're only beginning to glimpse, geometric lattices spanning unimaginable distances, signals from sources we cannot identify, a universe containing infrastructure built on scales that dwarf human comprehension. We cannot return to not knowing. We cannot pretend we never discovered these structures. The void exists whether we acknowledge it or not. The only path is forward into whatever new reality awaits. The Boötes Void stopped being an astronomical curiosity. It became a herald, an announcement that our universe contains depths we never imagined. That cosmic evolution follows scripts we didn't write. That intelligence, or physics beyond current understanding, shapes reality in ways we're only now detecting. We found something hiding in the emptiness, something vast beyond measure, something ancient beyond reckoning, something that changes everything we thought we knew about the universe and our place within it. And now it's waking up. Year by year, broadcast by broadcast, the voids become more active, more powerful, more impossible to ignore. Something is coming, something the voids have been preparing for across billions of years. The countdown continues, the structures approach completion, the signals intensify. We discovered this cosmic mystery just in time to watch it reach culmination, to witness the transformation, to learn what structured voids are for. The void was never empty, it never was. It contains the future, and the future is almost here. Look up at the night sky. Between the constellations Boötes and Virgo, 330 million light-years distant, something impossible is finishing its construction. A machine the size of hundreds of thousands of galaxies is activating its final protocols. We don't know what it will do. We don't know why it was built. We don't know who or what is responsible. But we know it's almost complete, and when it activates, when the countdown reaches 0, everything changes. The Boötes Void is the most important discovery in human history, not because of what it is now, but because of what it's becoming, not because of what it contains, but because of what it will unleash upon the cosmos. We stand at the edge of cosmic transformation. The voids are opening, the networks are connecting, the signals broadcast at full strength. And in the emptiness between galaxies, in the darkness we thought was void, something ancient remembers its purpose. The universe is about to remember too, and we'll be here, watching from Earth, as the greatest mystery in existence finally reveals itself. So where does this leave humanity? What do we do with this knowledge that fundamentally transforms our understanding of the cosmos? These aren't rhetorical questions. They demand serious consideration from every person who learns about the Boötes Void and its implications. First, we must acknowledge the profound shift in perspective this requires. For centuries, we've operated under the assumption that the universe is fundamentally understandable, that given enough time, enough data, enough brilliant minds working on problems, we can eventually comprehend how the cosmos works. The laws of physics are universal. Mathematics describes reality. Observation and experiment reveal truth. The Boötes Void challenges this comfortable assumption. Here's a cosmic structure that's been observed for over 40 years by the best minds in astronomy, studied with the most sophisticated instruments humanity has ever built, analysed using our most powerful supercomputers and theoretical frameworks, and we still cannot explain it through conventional physics. Every attempt fails, every model breaks. We're confronting the possibility, perhaps the probability, that reality operates according to principles so far beyond our current understanding that we might not possess the intellectual framework even to formulate the right questions, let alone find answers. It's humbling in the extreme, like bacteria trying to understand quantum mechanics. The conceptual gap might be simply too vast to bridge from our current position. Does this mean we should give up? Absolutely not. But it does mean we must approach this mystery with appropriate humility and acknowledgement of our limitations. We're not going to solve this through conventional astronomical observation alone. We need new tools, new approaches, new ways of thinking about cosmic structures and their purposes. The second crucial action is comprehensive monitoring and data collection. Every telescope capable of observing this region should be regularly scheduled for Boötes Void observations. We need continuous monitoring across all wavelengths, radio telescopes tracking the signal broadcast for any changes in frequency, timing or modulation patterns, optical telescopes watching for the next predicted dimming event, X-ray observatories searching for high-energy emissions, infrared surveys mapping temperature distributions. The data must be shared freely and immediately with the entire global scientific community. This is too important for nationalism or institutional competition. Every astronomer, physicist, mathematician, and computer scientist on Earth should have access to all Boötes Void observations the moment they're processed. Crowdsourced analysis, global collaboration on unprecedented scales. Someone somewhere might notice a pattern everyone else missed, might propose a model that suddenly makes sense of disparate observations, might bring expertise from an unexpected field that provides the crucial insight. We need every available mind working on this problem. Third, we should invest heavily in next-generation instruments specifically designed to study structured voids. Current telescopes were built for different purposes, studying normal galaxies, mapping cosmic structure, detecting exoplanets. They're not optimized for the unique challenges the Boötes Void presents. We need specialized instruments, radio telescope arrays with unprecedented sensitivity for detecting faint signals, gravitational wave detectors positioned optimally for the void's location on the sky, space-based telescopes with capabilities beyond Hubble and James Webb, specifically for continuous void monitoring. Perhaps even interstellar probes that could travel toward the void, getting closer for better observations over centuries or millennia. The cost would be enormous, but the importance justifies it. This is potentially the most significant discovery in human history. We should dedicate resources proportionate to that significance. Fourth, we must seriously consider the possibility of deliberate contact attempts. I know this is controversial. Many scientists understandably urge caution. We don't know what's out there or how it might respond to our signals. Making ourselves visible to something that can manipulate galaxies seems potentially dangerous. But consider the alternative. If the void is artificial, built by intelligences incomprehensibly more advanced than us, they likely already know we're here. Our radio and television broadcasts have been radiating into space for over a century. Any sufficiently advanced monitoring systems would have detected us long ago. Remaining silent doesn't hide us. It just means we're not participating in potential communication. If there's any chance the void signals are meant to be answered, we should answer, carefully, thoughtfully, with messages that demonstrate intelligence and peaceful intentions without revealing vulnerabilities or capabilities. The scientific return could be immeasurable. Communication with entities capable of building cosmic-scale structures would teach us physics, mathematics, and engineering beyond our wildest current imagination. Technology that makes our most advanced systems look like stone tools, knowledge that could solve every material challenge humanity faces. Of course, it might also bring unwanted attention or consequences we cannot predict. This is a genuine dilemma with no clear right answer. But doing nothing while these structures complete their activation sequences and we remain ignorant of their purpose might be the riskiest option of all. Fifth, we must prepare for multiple scenarios. The voids might activate and nothing visible happens. They could be performing functions on timescales or in dimensions we cannot detect. They might suddenly connect or communicate in ways that dramatically reveal their nature. They might begin expanding or transforming surrounding space. They might remain inscrutable mysteries forever. Humanity needs contingency plans for each possibility. If transformation occurs, how do we protect ourselves or adapt? If communication opens, who speaks for humanity and what do we say? If the mystery persists unsolved, how do we maintain scientific interest and funding over decades or centuries? These aren't questions with simple answers. They require input from scientists, philosophers, ethicists, policymakers, and citizens worldwide. The Boötes Void's implications extend far beyond astronomy into fundamental questions about humanity's place in the cosmos and our future as a species. Finally, we must educate. Every person on Earth should know about the Boötes Void and its implications. This can't remain obscure knowledge locked in academic journals and astronomy circles. It's too important, too transformative. Schools should teach about it. Documentaries should explore it. Public lectures should explain it in accessible terms. The global conversation should include everyone, not just specialists, because whatever the void represents, natural phenomenon or artificial construct, it affects us all. The universe is stranger and more complex than we imagined. The Boötes Void proved that conclusively. What we do with this knowledge will define humanity's next chapter. We can respond with curiosity, courage, and determination to understand, or we can ignore it, dismiss it, pretend it doesn't challenge our comfortable assumptions about reality. I know which path I hope we choose. The void is calling out across space with its impossible signals, its geometric precision, its systematic evolution toward completion. It's waiting to see if we're ready, if we're mature enough as a species to confront mysteries that dwarf our comprehension, if we have the wisdom to respond appropriately to phenomena beyond our understanding. The countdown continues, the activation approaches, and humanity must decide what role we'll play in whatever comes next. Observers, participants, victims, beneficiaries. The choice might still be ours to make, but the window for making that choice is closing. The void won't wait forever. Thank you for staying with me through this entire journey into one of the cosmos's deepest mysteries. I know this was long, but the Boötes Void demands comprehensive examination. There are no simple explanations here, no easy answers, just profound questions that challenge everything we thought we knew about the universe. I want to hear from you. Drop your thoughts in the comments. What do you think the void is? Natural phenomenon or something constructed? Is your mind blown? Are you skeptical? Have you thought of an explanation I didn't cover? And seriously, I asked at the beginning, but I'll ask again. Where are you watching from? What time is it there? The community you're all building in the comments section of these videos constantly amazes me. People from everywhere on Earth connecting through our shared fascination with cosmic mysteries. If this video impacted you, if it changed how you think about the universe or our place in it, please share it. More people need to know about the Boötes Void. This is too important to remain obscure. Subscribe if you want more deep dives into cosmic mysteries like this. Hit the notification bell so you don't miss future videos. We're living in an extraordinary time when our instruments are finally powerful enough to detect phenomena that previous generations never dreamed existed. The universe is revealing its secrets, and we get to witness it happen in real time. What an incredible privilege. Stay curious, keep looking up, and remember, the void is watching back.